Think of it as a game, a very deadly game. If you take off or land through a thunderstorm, about 3/4 of the time, you'll be able to lean back and congratulate yourself on being a hell of a fine on-time pilot. But what about the other quarter? Well, the statistics say that you'll encounter some combination of heavy rain, hail, severe turbulence, or lightning, with the potential to damage or destroy your aircraft. And one of those times, the odds say you'll encounter a microburst. You lose again. When the potential for severe weather exists in the vicinity of your departure or destination airport, pilots must realize there can be a difference between operating successfully and operating safely, and that the latter depends on more than good luck. Call it an attitude, if you will, or call it a strategy of avoidance. Just how much of a threat does severe weather pose to aviation? Well, in one form or another, it's been a factor in over 50% of every fatal commercial aviation accident over the past 20 years. For aviation, severe weather most often means convective weather. The tremendous energy generated by this process can result in heavy rainstorms, hail, lightning, severe turbulence, or severe wind shear. Convection occurs when the heat buildup at the Earth's surface warms the nearby air, causing it to rise. Since warm air has the capacity to hold greater amounts of water vapor than cold air, when it rises and is cooled, the moisture condenses, and the cooling sets up a downflow, either in the form of supercooled air, hail, rain, or in very dry conditions, virga, which is rain that evaporates before it reaches the ground. At the National Center for Atmospheric Research in Boulder, Colorado, the threat to aviation posed by hazardous weather conditions is taken very seriously. Dr. John McCarthy, a pilot and scientist, has been heavily involved in research on systems that can provide pilots with information they can use to evaluate the threat of specific severe weather conditions.
There are a number of important clues that pilots can look for to identify hazardous convective weather in the terminal area. An obvious place to look is the terminal forecast, to simply see if rain showers or thunder showers are forecast at your takeoff location or your destination. Another obvious place to look is in the sequence report of current weather, which is of course every hour, or any special reports, which suggests that convective weather is actually occurring at your airport of interest. Again, rain showers, thunderstorm, hail, gusty winds, and so on, blowing dust, another indication. So those are obvious clues we need to keep track of. Another important area is the convective SIGMET. These are reports that are issued by the Aviation Weather Analysis Unit at Kansas City, which uses the weather radar network around the country to identify thunderstorms and certainly severe thunderstorms when they impact the terminal area. We, of course, are always concerned about very low humidity conditions in which storms occur, and that can be identified by a large temperature dew point spread. 30 to 50 degrees Fahrenheit spread is a prime indication that a dry microburst may occur if convective weather also occurs there. There are other visual clues that are just as important. For example, a rain shower in a convective cloud situation that produces lightning. It's a dead giveaway. We've got a thunderstorm there, stay away. Another important clue is evidence of strong localized blowing dust near the ground. It may be circular, elliptical in shape. It may appear very turbulent. Again, you've got to stay away from those kinds of conditions. In this extraordinary sequence that shows the development of a thunderstorm and a microburst, we first see the development of a few cumulus clouds. that grow and dissipate very quickly. As time goes on, the whole area becomes more and more convective, and the clouds continue to bubble and grow and get slowly bigger and bigger as the day progresses. As they grow, they also begin to combine into larger and larger cumulus elements, and we begin to see a few little rain showers that form out of this complex. Typical of a thunderstorm day, they continue to grow and the whole area becomes darker and more ominous with more and more rain showers. Then on the left-hand side of the screen, we have an intense cloud, very dark, begins to develop and suddenly produces a tremendous downdraft, hits the ground, rushes out quickly to the right, and we see very turbulent eddies of the outrush from the rain cell. So again, it's a classical sign of severe weather that you absolutely must stay out of in the terminal area. An important resource for dealing with severe weather in the terminal area is the low-level wind shear alert system. The original LWAS system was composed of 6 sensors, which unfortunately were not able to detect microbursts very easily. The system is being enhanced to basically double the number of sensors to about 12 sensors, substantially increasing the probability of detecting microbursts. It's important to recognize that when the LWAS system alerts, it is a clear indication that wind shear is present over the airport. However, the absence of a wind shear alert may simply mean that the wind shear was not detected by the system, and a pilot should use other clues to maintain the critical vigilance that is necessary.
So there is information that crews can use to evaluate and avoid hazardous weather situations. But there also must be an understanding of how flight crews can incorporate an avoidance strategy in their day-to-day operations. Captain Patrick Klein, chairman of the Airline Pilots Association's Aviation Weather Committee, is outspoken on the subject.
When you report for a trip, you're going to go through a series of routine checks. So let's talk a little bit about what it is that you're trying to accomplish. At the very minimum, you'll have a sequence report and a forecast for your departure station, your destination, and your alternates. You really should try to obtain 3 hours of weather information for your destination and your alternate. With this information, you can do 2 things. You can note the trends, the weather trends for the stations that you're going to be operating into, and you'll also be able to validate or see just how accurate the weather guesser was when he made up the weather forecast. If he called for a change in weather an hour ago, see if it actually occurred. You also want to find convective segments and center weather advisories. These will let you know what kind of weather you're going to see en route. Let's say, for example, that you're going from Cleveland to Chicago. Ordinarily, that kind of a flight plan will take you over Toledo, Goshen, Indiana, a bit north of South Bend, and into the Chicago area. If you should see a convective segment that tells you that there are thunderstorms operating on the eastern shore of Lake Michigan, the prudent thing to do is probably to sit down and immediately refile your flight plan to, say, take you over Fort Wayne and Indianapolis and approach Chicago from the southeast. That's avoidance at its best. What I'm encouraging here is a mindset that says, what can I expect and what are my alternatives if I see things that begin to worry me as an operating crew member? Once you've answered that question, sign your flight plan and get on with the job. Now, weather avoidance requires that crews recognize conditions that pose a risk. But when a crew looks out the window and begins to make that assessment, I doubt that anyone looks at it in terms of, am I going to make this take off and die? Their thought process simply doesn't work that way. But thinking through the consequences of weather is important and must be developed through training and practice. It isn't new information to most pilots that it's unhealthy to fly into or underneath thunderstorms. So since you rarely have to wait long for the storm to clear the airport, wait. Holding is one of the things that crews do best. As you move out onto the runway, you should have your airborne radar on to see what's going on the departure route. You should be looking for visual cues. You should be listening for pilot reports from preceding departures and, most especially, be listening to what the local controller is reporting for LWAS or other PIREPs that were made when you weren't on the frequency. The point is to begin to establish what kind of convective activity is around and what its proximity is to the airport. En route, pilots do an excellent job of avoiding weather. They use their airborne radar. They have the airspace in which to maneuver so they can circumnavigate most of the hazards most of the time. But there are areas downwind of a thunderstorm that can be very hazardous. Anything that can stick 40,000 feet straight up in the air in 100-knot wind is nothing to be trifled with. Now that storm is really going to cause a lot of turbulence because as the clear air is displaced going around it, it will begin to churn and tumble. And it takes a fairly good amount of distance for that air to settle down and become stable again. A rule of thumb that you can use is to avoid the downwind side of a thunderstorm by a distance equal to 1 mile for every knot of wind at your altitude. But on the other hand, you can go fairly close to that thunderstorm upwind of it. You'll also find turbulence in the area within a mile or so of the right side of a thunderstorm looking downwind. When you approach the terminal area, knowing the speed and direction of movement of weather is extremely important. You can get that information off of a convective segment or a center weather advisory. Sometimes the approach controller can tell you, or you can determine it using your airborne radar. But that information lets you know where the hazards associated with a thunderstorm exist and what areas to avoid. There are lots of things about a thunderstorm that can get you in some fairly serious trouble. You can't see to land if your airplane's operating in heavy rain. If you manage to get through that heavy rain, if you encounter a hail shaft, you can do millions of dollars of damage to your aircraft in just a few seconds. If you make it through the heavy rain and the hail and land on a runway that's flooded with rain, stopping an aircraft in those circumstances can get to be a pretty dicey operation. We also know that there is a 1 in 20 chance that a thunderstorm contains a microburst. So operating in the vicinity of a thunderstorm near an airport is like playing Russian roulette. Maybe the odds are only 1 in 20, but if you're wrong, it's going to ruin your whole day. Now, when you hear a pilot report of significant uncommanded airspeed changes from a flight ahead of you, you should always assume that the condition will be worse for you than it was for the guy that encountered it. It's wrong for pilots flying heavy iron to assume that the small airplane in front of them is encountering a condition that they can overcome simply because of their size. That's not the case. The size of the aircraft that reports the encounter is not significant. It's the change in performance that counts. Anytime the convective weather is within 3 miles of the airport, crews should begin to consider things like, do I want to make a missed approach off a runway that will put me into a thunderstorm? And the obvious answer is no. If I can change runways and continue to shoot the approach and have a clear departure path in the event of a go-around, that's the prudent choice. Pilots have to be willing to accept the fact that they are at times going to make a conservative call. But that's exactly what everybody wants them to do. I think it is literally true that there are weather conditions which pilots will encounter that are unsurvivable. When they recognize that they are in trouble, they are, for all practical purposes, dead. Pilots need to keep in mind that they are the ones that make the final determination as to whether to operate. Air traffic control can clear you for a takeoff, but they can't advance the throttles. They can clear you for an approach, but they can't steer down the localizer in the glide slope. That's the crew's decision. They know their capabilities, and they know the capabilities of their aircraft. No one else has that information. It's absolutely essential that captains exercise the discretion that goes with their job.
One more point. Since convective weather is dynamic, pilots must use all of the information that is available to them and continually reevaluate their decision to continue. The onboard weather radar can be one of the most useful tools available to pilots in situations where severe weather may be a factor. It is, however, only a tool. It is intended to be used as a weather avoidance device, not a weather penetration system. Now, in most instances, radar will detect rain and large wet hail, but snow, small dry hail, ice crystals, fog, or clouds will show up as very weak echoes, or more often, as nothing at all. All radars allow the operator to adjust the tilt of the antenna, and proper tilt management is one of the most important factors in using any radar to its maximum effectiveness. For instance, by scanning a storm cell in the vertical direction with small, slow changes in the antenna tilt angle, pilots can determine a storm's profile and identify areas of maximum rainfall intensity. In situations where the rain is extremely intense, a phenomenon called radar attenuation may occur, since very heavy rain will absorb most of the transmitted energy, and returns beyond the heavy rain cell will be very weak or non-existent. Pilots can determine if this is occurring by adjusting the radar tilt down to the point at which they would normally expect to see ground clutter. If the radar signal is being attenuated, there will be no ground return beyond the rain cell. This is called shadowing, and simply stated, with the antenna tilted down, never fly where your radar does not show a return where there should be ground clutter. On the runway, rotating the antenna upward may give crews the information they need to avoid severe storm cells during climb-out. Now, let's sum things up. Again, Dr. McCarthy.
I have a very simple message for all pilots, and that is stay out of thunderstorms in the immediate terminal area, and I mean right ahead of you, whether you're taking off or approaching to land. I'm not talking about a thunderstorm over there beyond the airport. I'm talking about right ahead of you. You're below 1,000 feet, and that's what's ahead of you. You've got to stay away. It may contain heavy rain. It may have hail. It may have severe turbulence. It may have a microburst in it. Or the worst possible thing is a tornado embedded in it. We just don't know which thunderstorms are the most severe and which are not. So you've got to stay out of all thunderstorms, period.
The ability to develop an effective strategy for avoidance depends on pilots understanding the nature of convective weather and being able to assess the risk potential so they can make informed, pragmatic decisions before entering a severe weather condition that could prove to be non-survivable. Finally, and maybe most important, make use of the information that's available and develop a strategy of avoidance.